Well, good morning, good afternoon, good evening to everyone, wherever you may be across the world and across the interwebs. Thanks so much for joining us here today, live for Serverless Office Hours, streaming on AWS Twitch and also on the Serverless Land YouTube channel. So my name is Julian Wood. I'm a developer advocate for serverless here at AWS. And this week is all about AWS messaging and events. And I'm super happy to be joined by the awesome Sam Dengler. How on earth are you, Sam?
I'm great, Julian. Thanks for having me.
Absolute pleasure. Well, we're super happy to have one of the true experts. Sam is a proper guru for serverless, let me tell you. So you're lucky to have him, a principal serverless solutions architect. I think, Sam, you've been at AWS more than 5 years, is it?
Yeah, I'm coming up on 6. Hard to believe.
Wow, coming up on 6. So Sam knows all the details, and Sam, you've worked in some various different parts of AWS serverless, haven't you?
Yeah, so I started my career at AWS as a generalist solutions architect, but as a customer, I was we're at reInvent when Lambda was announced and adopted at our startup. So I've been working with Lambda since it came out, and really enjoy the ability to build quickly, and the agility it gives me, and really like to see the results of what I built fast. So I've stuck with it and was lucky enough to kind of move into more of a specialist role a couple of years ago.
Cool. Awesome. Well, we're so happy to have you today to be talking about all the cool stuff. We're going to change the format slightly today because Sam actually needs to head off a little earlier. So yeah, some of the blogs and things we normally review at the beginning, I'm going to do at the end just to give Sam as much possible time to show you all his awesome stuff. But just to remember that last week we did have Serverless Surprise was the theme. And it was super cool because we actually had a Serverless Heroes and Community Builders, Talia Nassi. Oh, sorry, Talia, I messed up an I on your name. It was Talia Nassi. I was joined by Ben Ellaby and Alex White. And they were looking at 2 open source tools, which are really useful for when you're building serverless applications. So if you look on the Serverless Land YouTube channel, that is the episode from last week, which is available for your viewing pleasure. But this week, as I said, AWS messaging and events, and it's over to Sam. And we're going to be talking about basically processing DynamoDB change data events. Sam, as this sort of obvious leading, what's a DynamoDB change data events?
Yeah, so whenever you update changes in a DynamoDB table, as of March 24th, there's now a CloudTrail data event that's produced as far as that change. And so you might be familiar with CloudTrail data events from S3 events. So for a long time now, when you update items inside of a bucket, that produces a CloudTrail data event as well for those things. And it's useful for building event-driven systems that respond to changes in S3 buckets, as well as providing additional context around the identity that operated in that, so you can build security applications in order to inspect who's making those API calls and making those data changes too. So in March, the team took the same approach and applied it to changes to DynamoDB tables as well.
So yeah, when people think of CloudTrail, it's normally thinking of auditing and tracking, and it's something that maybe your compliance or governance people would be using. I know CloudTrail with S3 is a bit of a sort of slightly different use case. Yeah, how should people think about sort of what CloudTrail is meant to be used for in that context?
Yeah, so I think you're exactly right, Julian. CloudTrail is the record of all the API calls that happen in your account. So it's a critical source of truth for everything that happens in your AWS account. And it not only includes the API operations that happen in the account, but also the AWS identity, the IAM user or role that was used in order to take that API action. And so it's an incredibly important place to track who's operating in your AWS account and what's happening there. The data events are an additional capability that you can add to the CloudTrail log, where you can choose which DynamoDB tables or S3 buckets and monitor those for data changes as well. So when items are created or deleted or changed inside of those 2 data sources, then it produces an event on the CloudTrail log as well.
Excellent. Thank you very much. Well, yeah, and just obviously we're broadcasting live, so if you do have any questions, please hit them up in the Twitch chat or the YouTube chat, and yeah, we'll be happy to answer them. And yeah, having one of the gurus, Sam, over here makes my job much easier when Sam can answer all your burning questions. But yeah, questions from today or about serverless stuff in general, we'll be happy to take your questions. Sam, so do you want to share your screen yet, or what's
Sure,
best for you?
That would be great. Yeah, that would be great.
Always.
Share my screen and I can kind of walk through some of the details of what CloudTrail data events are and how we
Cool,
can
excellent.
use them building event-driven architecture. So
Yeah, just before we go, if you just want to hit the hide button at the bottom of that screen, that'll just remove that little blog. And if you just zoom in a little bit as well, some of the old people like myself in the back need a bit of better vision with the text on the screen. So
is that big enough?
You can still read it. I think that should be good. I think.
Okay.
Tell us in the chat if you can't see.
Thanks. Yeah. So as I mentioned in late March, we added CloudTrail added logging of data events for Amazon DynamoDB, and in the What's New blog post, it really focuses on the security aspects of that. So having the additional context on who's making changes to tables, opens up a lot of opportunities in how you can do governance and get insights into who's actually doing data manipulations in tables. So it's really, the launch announcement is really focused around these security aspects of it, but actually it's in a general purpose way, it's very useful for building event-driven architectures in the similar ways that you might process changes to S3 buckets using S3 data events as well. And in the past, you might be more familiar when you're processing changes to DynamoDB tables of using the serverless LAN pattern that shows how we can tie a Lambda function to a DynamoDB stream. And this is a great way of processing changes to tables as well. In a little bit, we'll talk about some of the comparisons between the data events and the stream events. But as part of the serverless LAN patterns, we have an example of where we tie a Lambda function to it. Any records that are written to the DynamoDB table are included in a stream of records, an optional stream of records that you can enable, and you can process those as well. There's also a great post by James Beswick called Understanding Data Stream Concepts for Serverless Applications that goes into the details of this type of stream processing. So this is definitely still a good practice for processing changes to data. And we'll look a little bit at the differences in the type of data that you get from a stream event versus a data event. And it might help you guide what would be the right choice for you.
Yeah, that whole blog post series is super good. It is slightly more focused on Kinesis, but the data stream event that you get from Kinesis and you get from DynamoDB, you can think of it as the same kind of thing. But it's nice to sort of, with that blog post series and that particular blog post, is to understand what data streaming is. Because some people do struggle with it. I know when I started looking at all of this, that the concept of streaming data was a little bit odd to me. So yeah, understanding what streaming data is and things like ordering and how a stream is separate. A stream of data is separate from a particular event is super important. So yeah, look at James's excellent blog post series, and it'll give you a lot of sort of background information on why streaming may be helpful to you.
Yeah, it's a great call out too, right? Is that we see stream data processing across several AWS services, and some of the things, there's some slight differences in how it operates differently with Kinesis data streams and DynamoDB, but generally, like, these best practices and concepts are really transferable across the services. In the demo I'm going to walk through, I wanted to point out that there's a great set of source of example information data, table definitions and data in the DynamoDB documentation. And we're going to use that as part of the demonstration today. And so in our demonstration, we're going to focus on two tables from this second use case called the forum application. One where we'll create a thread table that keeps track of a forum name and a subject for a message thread in the forum. And then the second, we'll expand on that example using a reply table, which is related to messages that occur within, replies to messages within a thread. So the data that we look at in this example, you can also find on yourself if you want to reproduce these examples. So to get started, of course, we're going to process changes to a DynamoDB table. So we need to create a DynamoDB table to do that. So I have my AWS console open, and I'm at the DynamoDB service console. And I'm going to go to tables, and I'm going to create a new table. And in this table, we're going to call this table thread, because first we're going to look at a simple example using threads. And based on that table definition that we looked at in the DynamoDB documentation, we're going to have a partition key called forum name and a sort key called subject. Now, if you looked at DynamoDB before, you know that the partition key is particularly important on how updates to the table are well distributed across the partitions as DynamoDB scales out over time to handle consistent throughput to your tables over the partitions. And then we can add multiple sort keys optionally if we would like, in order to provide additional dimensions and create composite keys on the table as well. So here we're going to have essentially a forum, which would be common across multiple subjects that are updated in that table. The other thing I'm going to do is I'm going to customize the settings in this table, because I would like to choose on-demand capacity mode for the table. What this means is that I am only paying for my usage of the table. So when I make requests to the table, I'm sort of billed on those individual requests. So it really fits a serverless billing model that you might already be familiar with Lambda functions and other SQSQs and the sorts of pay for usage services. There is a capacity calculator, and you can look at a provisioned capacity as well. So in certain cases, it's a better deal if you can determine the amount of capacity you need to a table, and you can manage that. But one of the nice things with the on-demand is you can set it, and much like other serverless services, you're only paying for when you're using it. The next thing I'm going to do here is I'm going to create the table. And once this table is created, we're going to demonstrate the differences between the data events and the stream events. So on this table, I will create a DynamoDB stream so that we can see what the data looks like coming off of the stream. And so let's see, it should just take a second here. So our thread table is active. And so I will go to exports and streams, and I will enable a DynamoDB stream. When you enable a DynamoDB stream, you have some choices on what type of data you would like to receive in the stream. And this is going to be important as we look at the differences between what you see in the data events. So if you would like, you can only get the key attributes only. So you get the keys and their values for either the partition key, or if you're using sort keys, that set of key information. And then with DynamoDB streams, you have three choices. You can receive the new information, what's the new item. You can receive the old information, or you can receive a record that has both the new and the old item for you to make a decision with. So in this case, in order to show more of an exact comparison with what we see in the Dynamo data events, I'll choose new image, although you can make this choice based on what makes sense for your application and processing the stream updates. And I will enable the stream. Now the stream is enabled, which means their DynamoDB is spinning up a set of resources that will monitor your changes to the table and then represent those changes on the stream for you to process those. The second thing we need to do is add a trigger. So as those records are being written to a stream, we have something that is reacting to those records. And when we create a trigger, this will be a Lambda function. And I've already created some Lambda functions already. And these are very simple Lambda functions, which are simply going to log the results of this data so we can take a look at what the structure of the data is. With DynamoDB streams, when you have a trigger, you can choose a batch size. So this is going to be a difference we'll look at in a minute. The batch size can be anywhere from 1 to up to 10,000 records in a batch. So you do have batching capabilities. So I will go ahead and create this trigger. So now anytime I make a change to a DynamoDB table, my Lambda function should get triggered with some data, and we can see what that looks like. Okay, now in order to set up, so now we have DynamoDB stream. We're going to capture the updates to the table through a stream. We wanted to do the same thing except for the CloudTrail data events. So in order to do that, we go to CloudTrail, and we'll create a new trail. And when we create this trail, we'll give it a name like DynamoDB data events. And in this case, I will create a new S3 bucket in order to store those events. And I'll keep the KMS key encryption is the default. That's a good practice, so I'll keep that. And I will create this stream. Oh, I already created one like this. Let's see. And here I will create an alias for my KMS key as well. Okay, now here I will choose to what type of events that I want to log. Okay, so when we create a CloudTrail, we can choose what type of data we want to capture in that CloudTrail. So management events, again, are all sort of the control plane operations that you would do with API calls. If you're going to modify the configuration of an S3 bucket, if you're going to create new resources, create tables. So these types of, we call these control plane operations or management events. They're different than data events, data that's flowing through some of our AWS services.
So the managed events is what people would think of when previously they used CloudTrail. As I mentioned before, you want to find out who's done what on something, and that would be your auditing and governance and compliance kind of stuff. And then your data is actually the data that's going in and out of that. And as you mentioned nicely before, if you look at the data events, you're also getting some of that metadata about who did what.
Yeah, that's a great point. It's nice that CloudTrail is adding that context to both cases, and you do essentially want to ensure that you are capturing the management events in some sort of CloudTrail as a best practice, security best practices in AWS. And in this case, though, we can create a CloudTrail that's specific to process the data events. So I can uncheck management events and choose data events. And when I'm doing this, I can select what is the data source for those events. So as I mentioned, the S3 data events through CloudTrail have been around for a while, but now we can actually choose DynamoDB as a new source for where we can look for those data events. Now I could choose to indiscriminately monitor all operations on all tables moving forward, but I actually want to control that a little bit more, and I want to provide the table that we created in the previous step. So if I go back to my thread table example, here we can see the Amazon resource name. And I'm going to copy that and use that as my table that I want to monitor. And here I can choose whether I want to monitor read or write operations. In my example, I just want to monitor what happens when we do updates to the table. So I will click write, and I will click next, and then I'll create the trail. Now it's important to note, if you look inside the CloudTrail documentation, there is something that says that changes that happen in the CloudTrail will be made available as an event in somewhere around 5 to 15 minutes. And some of that is there's a difference in behavior when we're talking about management events and data events. Management events can sometimes have a delay as we do batch processing on processing those management events, but the data events don't follow that same behavior. So they're not instantaneous, but they have really low latency between when those events occur inside of the data source and when you can actually process them in your event-driven applications. Okay, so we have our new DynamoDB data events. And next thing I want to do is we are going to create a rule that's going to process these data events. But at first, it's important to understand what is in that. What's the structure of that event? If we want to create a rule in EventBridge that can filter and decide which events we are interested in processing, it's helpful to understand what is a sample event that we can look at for that. And so here is a sample event from the CloudTrail data events. And so you'll notice, as we mentioned, Julian, there are some common information that happens across all CloudTrail events. This is the user identity section, for example. And this user identity describes the principal, the AWS principal that actually issued the call. And then there's going to be different information that's specific to whatever the data or the management or data event was. So notice in this case, when we receive a data event from DynamoDB through CloudTrail, there's a couple of interesting pieces of information that we can use. First is we have the event source. The event source tells us what is the actual data source, whether this was S3 or DynamoDB. We also have the event name. The event name is going to tell us the API operation on that resource. So here is when we're actually putting an item in the table. And then there's some specific information in the request parameters that tells us the table name, what was the table that was updated. And then we have some specific information about what was updated. So for the key on the table, we can see the actual keys. So here we have the subject and forum name, which remember forum name was the partition key and subject was the sort key. And we actually get the values for those as well. So we have the values, the keys and the values for the table key are represented. And then we have a list of the items. So this is going to be a difference when we look at what's produced in CloudTrail data event, in the DynamoDB streams events, is we don't actually have all of the data like we did in the stream event. Okay, so the next thing we want to do is actually go create a rule that we can process this event. So once CloudTrail has produced this data event, we want to be able to process that. So we will go to the EventBridge service. Now, EventBridge is the sort of native event bus inside of your AWS account. all of the CloudTrail data events already go to this, the default event bus in your account. And EventBridge offers you the ability to create custom event buses for your own applications as well. So to process the data events from DynamoDB, I will go and create a new rule. Because all the CloudTrail data events go to the default event bus, I will create a rule against the default event bus. Creating a rule in EventBridge is really easy. You provide the rule name. So in this case, we'll just call this DynamoDB updates. And then we describe a pattern. So the pattern is, how are we going to match the payload of that data so that we can decide if this is something that we're interested in processing or not. So when we do that, we can choose an event pattern. And when we choose that, we can decide what is the structure of that event that we would like to do. And this, essentially the filter that we're going to write here, the rule, is going to match the data that is coming in through the event. So here we'll select AWS events. We'll pick DynamoDB as the event type, and we will pick these API calls. So now remember, says now we're looking for something that has a source from DynamoDB, a detail type of CloudTrail, where the event source detail is dynamodb.amazonaws.com. If we go back and look at our sample event, we'll see that the source is DynamoDB, the detail type is API call via CloudTrail, and the event source is DynamoDB. So that gets us part of the way, but we might want to add a little bit more information in order to further constrict the type of data that we're interested in. So what we can add to our rule, in addition to being interested in the updates to the event source for DynamoDB, we can also say we only want to know things that happen that are related to put items to the database. So this is
Sam,
a key
sorry, can I just interrupt you? Just can you zoom in a little bit over there?
Oh, yes.
Just going to be a bit tough to read. Thank you.
Sure. So this is going to be a difference that we have with DynamoDB streams. We'll see in a second. We can be really specific inside of the rule on what operations or even the key values that we would like to do to filter on what information we're interested in and what target should be triggered as a result. So here, I'm restricting my interest to only updates to a DynamoDB table. If there are, if we delete items or we're reading items, other types of changes to the table, these will not trigger the rule. Then the next part of this is we want to choose what should we trigger. When this rule matches, what is going to be the result of that to react to it. And here we'll pick another Lambda function as an example that will just log the output so that we can compare the two. Okay, and that's it. So we've created a rule, we've created a target, and that's all that's required in order to use EventBridge in order to react to things that are happening inside of your AWS services. Okay, so next, so now we have the DynamoDB stream set up, we've got the CloudTrail data event set up, and we have Lambda functions in both cases listening so that we can log the result. So of course, the next thing we'll want to do is actually send a sample event. So we'll go to our items in the console, and we'll go to thread, and we'll create a new item. And this, we're actually going to add an item to the DynamoDB table. And let me copy and paste this example here. So this example, we have the forum name. Remember, this is the partition key, which is Amazon DynamoDB. And we have the subject, which is the sort key, DynamoDB thread 2. Okay, and so let's create this item in the table. Okay, so now we've actually put an item into the DynamoDB table. So we should expect both triggers to fire, one that's through the DynamoDB streams and one through the data events. So let's go take a look at that inside of our Lambda console. Okay, so here we have both the EventBridge logger and the DynamoDB stream logger. Okay, and so here you can see the code for this, as I said, was very simple. We're just logging what the result of the event is so we can get a sense of the structure of the event. So to see what that is, we can go to our function and click on View Logs for this function. Okay, and we can see where our function was just executed. We can open our data and we can actually look at it and see that this is the data that came through the EventBridge data event. And this matches the example we were looking at before. So we can see the keys and the actual information around the keys, and we can get a list of the items that were updated. On the other hand, let's go look and see what we get inside of the DynamoDB stream data. So we go look here and view logs. Okay, and let's take a look at the result here. And we'll see here the data is different, right? So we're getting a list of records, and in each record, we have different information. The structure of the data is different, and we actually have the information. We have the new image, and it's showing us the new values. So it's important to note a couple of things, right? Is that the structures of these events depend on where they're coming from, and they can change. And we get different information inside of the DynamoDB stream than we do from the data events.
Sam, do you mind just jumping back to just so people can contrast back with what the streamed one looks like?
Yes,
sorry, what the EventBridge one looks like. Yeah, so this one has now got the actual data, the field data that you added to the table. And when you jump back to the one that came via CloudTrail via EventBridge, yeah, that has just the items, not actually the field level data.
That's right. Just sorry, Julian. Yes, we only have the names of the fields that were updated, but we don't have the data.
But you have the principle which created this, the fact that it was a put item, and a whole lot of metadata, even things like source IP address, for example. Yeah, a whole bunch of stuff about who did this action.
Yeah, so from a security insights point of view, having this type of information is really something that we've never had before. That's not available inside of the DynamoDB stream event, right? We just have information about the data, but not about the context around the update. Okay, so let's take a quick look at some of the trade-offs then. We have two different ways now that we can consume data on both from a DynamoDB table. Let's look at the differences. So when we use data events are through CloudTrail, and we have stream events. Okay, so a couple things to consider when you're trying to figure out what's going to be a good fit for you. One is around the ordering guarantees. So with EventBridge, data events through EventBridge is there are no ordering guarantees. With streaming events, we do have in-order processing at the partition key level, which means that on the stream, you will get an ordered updates to items that have the same partition key. So it's not a total global ordering, it's based on the partition key, but you do get in-order data updates. Delivery semantics means how can we expect that message to be delivered and how should we process it? With EventBridge, again, we have at least once delivery of messages, so we can have duplicate deliveries of messages. With streams, we have exactly once delivery. On the filtering side, so you saw inside of the rule that we created is that we can filter on the table name, we can do on the operation, we can also do on the key value pairs along with the actual key values as well. On the stream events, there is no filtering capabilities, right? So we're receiving all of those events and it's up to our code in order to write code inside of our Lambda function to decide which records to process and which ones to pass on. When we think about scaling the two, so CloudTrail is sending those data events directly to EventBridge. Again, this is a low latency events directly between these AWS services. So there's nothing for you to scale as far as how quickly you want to process those events. Any sort of scaling constraints in processing EventBridge events are based on the scaling behaviors of the consumer. So if you have a Lambda function, for example, it'll be how quickly that Lambda function can scale, or a step function's workflow, or whatever is the consumer is going to be your scaling constraint. When we're doing streaming events, the default behavior is you'll have one Lambda function per shard. So as your DynamoDB table gets larger or you ask for more read or write capacity units, DynamoDB will do horizontal sharding of the data, and you'll have one Lambda function per shard. We've also introduced another capability called parallelization factor. So that means you can add up to 10 Lambda functions per shard to get more throughput. It's important to note that even though you might have multiple Lambda functions processing the same shard, is that DynamoDB stream still and Lambda still guarantee the in-order processing at the partition key level for that. So in some cases, the scaling characteristics of DynamoDB streams fit, and in some cases, customers want even wider scaling behaviors, and that's something perhaps the data events can offer you. On the batching side, EventBridge does not offer batching capabilities, so you'll process each event as it comes through the bus. On the streaming event side, you have two choices. You can process up to 10,000 records per invocation. You can go anywhere from 1 to 10,000 on that. And there's now a new capability called batch window. So you can wait for a certain period of time in order to collect multiple records before you invoke your downstream system. So this can be useful, especially around, I think around cost optimization, perhaps, right? Where you want to make sure you're gathering a lot of records before you invoke a function. So those can be useful on the streaming side. On the target side, EventBridge today supports over 28 AWS service targets, and that includes Lambda functions and Kinesis data streams. For streaming events, we can invoke Lambda functions as we've had, or we can do KDS streams too. So those are our two choices there. So there's, like most things, there's not a right answer for all solutions. It really just comes down to, what is going to be the right path for you in order to build your event-driven architecture.
Well, what do you think would be a particular use case for people who are already using the stream events? What would be a use case that you can think of that people would go, data events, that's useful for me?
Yeah, so I think one in particular is when you might find that your Lambda function that's processing your DynamoDB streams is having to filter out a lot of the records, right, that aren't coming through that you don't need to process, right? And so that could either be on the type of update to the table, right? So TTL sort of expirations will also fire a record on the stream. And so, just based on how you're consuming the data on the stream, you might find that your Lambda function is invoked quite frequently, but is mostly, filtering out things that are happening in your tables. So I think that would be a really good choice, perhaps for data events, because you can be really specific about the updates to the tables as well as even the records that are being updated in the table that you would like to process.
Yeah, that's a good one. I mean, I also, whenever we talk about EventBridge, it's such an excellent way to think about building event-driven applications. And for people who don't quite understand about building event-driven applications, the idea is that everything in your infrastructure, everything in your application just becomes an event. Put it on the EventBridge event bus, and you just create rules that pattern match as a filter, and you send things around. And so one of the really cool things about EventBridge is its flexibility, because with a stream event, if you've got a lot of different data things that you want to stream, you may have a Lambda function and you want to do some filtering, but that Lambda function is going to get bigger and bigger and bigger, for example, because it's going to say, well, if the record includes this, do that. If the record's going to do this, do that. With EventBridge, you just have separate rules. The rules you don't have to manage a single Lambda function. You can have a number of rules with an event bus, and it's just a really flexible way that you can create and delete rules as you wish. The rules can go to different destinations. Looking at the bottom there are 28 targets, but technically it can even be more because EventBridge supports API destinations. So literally you could send this data to any API on the internet, for example. And yeah, EventBridge is just a really flexible way that you can, when you don't quite know the future changes you're going to have and where you want to route events and where you want to route data, EventBridge just makes that really simple for you.
Yeah, I really like it for those reasons too. It really, I think, gives you the right tools in between your sources and targets in order to be able to route those and connect the two without writing a lot of code to do so. And I also like you were saying, Julian, right, is that it really allows sort of these independent and decoupled systems where different subscribers can come to a bus and specify the rules for the data that they're interested in and have flexibility in what it chooses to target inside of their own applications without impeding on any other subscribers on the bus as well. So, I think EventBridge offers this really nice decoupling between producers and consumers, so they can kind of each do their jobs and do them well, but not potentially impact each other as they're processing the same type of data.
And they don't need to know about each other. The consumer doesn't need to know. The producers and consumers don't need to know that each other exists. Obviously, the producer needs to produce something initially, but the consumer, you can just keep adding consumers without having to change your producers. Kinesis just had an interesting question. If we want to sync DynamoDB between AWS accounts, is it better to use Streams or EventBridge?
So I would recommend streams. We do hear from customers that want to use eventing for synchronization. And although you can do it, I think, by nature, events are unordered and can occur in duplicate. I mean, if we think about sort of outside of the technology sense, right, when we can hear about things multiple times, and when we hear about them can be out of order. And so when we're thinking about data synchronization, if you want to put the data that should be synchronized in the message, essentially, that's flowing through the two systems, then I think it's more important that you're using systems that support ordering and exactly once guarantees. If you choose to use an eventing structure instead, you might not choose to include the actual data in the event. So notice in the event, the DynamoDB data event, other than the identifying data around the key that was updated, the data is not included. And so that can allow you then to signal other system that data has changed, but not actually tell them what data did change. And it kind of has a little bit different pattern where you're signaling other systems that state has changed, but then it's up to those systems to come back to the source of truth in order to determine what changed. And so that can help with sort of troubles and eventual consistency when data is changing in one system and you're trying to synchronize it in others. If you're putting the actual data that's being changed in the event and trying to get this really strong guarantees around synchronicity, you won't end up with those. You'll end up having to reorder events on the downstream side, and that's certainly something you do build in event-driven systems or deduplication mechanisms. It's called item potency, and there's great tools in the Power Tools, Python Tower Tools, for example, for Lambda. There's some great utilities around item potency, or you have to implement reordering mechanisms as well. So in the case that you do get out of order events, how do you reorder those events and update the systems to handle that? So you can do it in sort of a data event, but it requires you to build more around the events in order to have those types of ordering guarantees that can come directly inside of the stream events.
Yeah, and also if you're not going to be using filtering, I mean, the big power of the data events is using the filtering. If you're syncing, you're generally not going to be filtering. So yeah, I would think using the native streaming would be better. Thank you, Kinesta, for your question.
That's a great question. So yeah, I think that's really what I wanted to kind of go through a little bit more of another example, but I don't think I have quite time to do it. But I'll just kind of propose another case for this, right? In this case, perhaps we want to actually enrich our data, right? So, you might say, well, I really like actually getting the DynamoDB stream data inside of the message that's coming from the table. If that's not present inside of the data event, then isn't that a disadvantage, right? And I kind of like to think of this in a similar way that when we get S3 data events, right, we don't actually get the full object that comes through. We get certain, the key information and certain metadata information that we can use to do some sort of header-based processing. But ultimately, we want to come back to that source of truth and pull more of the data. And so you can imagine a scenario where, through EventBridge, not only can we trigger a Lambda function, we could also trigger a step function. Maybe I could just show you that really quickly on how we can trigger a simple step function as an alternative to a Lambda function for processing events. So what we'll do is we'll keep the same table that we have in the same records, and we'll come back to, we'll actually go and create a step function workflow to respond to the changes in data, not just the Lambda function, some functional code, but actually a workflow to respond to those. So we'll come here to the state machines inside of the step functions service, and we can create a state machine. Step functions, if you haven't used it before, is a way of describing workflows or state machines that respond to events and can have more control over the order or sequences of processing, more built-in integrations with other AWS services, and allow you to sort of describe that business process or workflow in a declarative way versus having it described in code. And maybe about 4 or 6 weeks ago, Step Functions announced a new visual designer called the Workflow Studio, which is, from my conversations with customers, has been a game changer for how easy it is to build workflows. It certainly has been for me too, as I work with Step Functions. So we'll just create a very simple workflow just to kind of demonstrate how we can connect the two as an alternative to Lambda functions. So here, we have a sample workflow. This is the visual editor. And you can see I have my options here and what I like to plug into my workflow on the left. And on the right, we have some details on our the things that we're adding. So very simple sort of hello world scenarios where we have a past state inside of step functions, which means there's really just no integration or data processing. We're simply just receiving the data. And we'll just call this a past state. And that's all it's going to do. We're basically just going to receive that and see what the data is that was received. And we can save this. So here, this is actually called the Amazon States language, and this is the JSON representation of that visual workflow that we created. And you can see that we basically just have a state that is just a pass-through state. It's very simple to set up as an example. And we'll just call this the pass state machine as an example of kind of to see how this might work. Okay, so we have the past state machine, very simple. Now we might want to hook this up into EventBridge. The same rule that we had before in order to capture updates to that table. But in addition to invoking the Lambda function, maybe we want to invoke the step function workflow too. So we can come back to our EventBridge, and we can come back to our DynamoDB events. And let's edit this rule. So we want to keep the same rule pattern. We have our Lambda function that we were targeting, and we can add a second target here. And in the second target, we can come to step functions, and we can select the state machine that we created, the past state machine. So here, one rule matched one type of data that we're interested in is actually triggering two things. It's triggering the Lambda function and the step function state machine. So let's go back here, and let's save our changes to the table. And let's see if our step functions workflow will execute as well. So here, one of the nice things, in addition to the actual definition of the workflow and your ability to design these visually, and it's useful for communicating those, step functions is also responsible for scaling the execution of those workflows as well. So here we go. So the event came in through CloudTrail data events, matched the rule in EventBridge, and then EventBridge triggered the step function workflow execution. And if we look at the execution in step functions, we can actually step through the steps in the workflow and see what happened. So if we look at the past state we created and we look at the step input, you'll see that we have the same structure of the data that our Lambda function was receiving instead. And so this is another processing alternative to the Lambda function for processing the data. And we can choose if we would like then to enhance the state machine, right? So there's lots of things that we can do inside of step functions, including, for example, using an integration with a DynamoDB table. So we could, for example, get an item, right? And so we can start to build a workflow that will allow us to process that data and integrate directly with AWS services, expect the data, and make choices based on what we would like to do and process. So I think being able to trigger things through EventBridge outside of Lambda functions just opens up a lot of possibilities in the type of applications that you might build using other AWS services.
Oh, that's fantastic. And I love just going back to the beginning where you had everything in EventBridge and just added another target to the same rule means you making very little breaking changes to your existing application, add it straight into step functions. You can go and then iterate as much as you want on step functions, knowing that your Lambda function is still processing. And here, look how simple it is. Step functions, Workflow Studio, you can then, because as Sam said before, you're only getting the metadata, you're not getting the actual data. Well, here you go, get your step functions to go and get that data. And then as DJ Josh D says, could this be used to validate correct data? Yes, it could. So yeah, you could have a whole workflow that could be used over here. Remember, the data is already written to DynamoDB, so it's not an in-flight validation correcting data. It's after the effect, asynchronously. But yeah, DJ Joshua G, exactly. Step functions, an amazing workflow studio. With the Workflow Studio, you build your step functions, and you can do anything. So yeah, fantastic. Sam, I know you need to go, and I'm sure you want to watch. I want to show us lots more, and there's lots more you can do. So, is any final parting words, or are you just going to forget what you're doing entirely, and you're going to stick with us for many more hours and explain some more? I think not.
I wish I could. I'd love to come back again and show you some more examples, but I hope this is not everyone, I think, has discovered this new feature. So hopefully this is sort of something new to the listeners and kind of opens up some possibilities for the type of applications they might build using EventBridge and the data events.
No, thank you very much. Yeah, and this is superb for bringing it to light. I remember reading the blog post about this, and I did sort of understand it and sort of scratching my head what the use cases were. And you've brought it all to life and shown some excellent use cases. So, yeah, Sam, thanks so much for joining us today. And you're always welcome back on Serverless Office Hours. So can't wait to have you back, and hopefully see you in person sometime when the crazy worlds are sorting themselves out.
Likewise, yes. Thanks so much. I appreciate it.
Pleasure. Cheers. Thanks, Sam.
Thanks.
Oh, sorry, I think I just cut him off just before his goodbye. Well, yeah, I just want to say that was a really helpful and useful way that we can talk about processing the DynamoDB change events. But actually, what I want to just talk about quickly with that is the power of the event-driven applications and how you can take something like EventBridge and the event bus as the heart of your applications. You could just put events onto the event bus, and then what you can do, you can get Lambda to listen to them. You can go to 28 different destinations. You can use API destinations, which is sending an event onto any API endpoint on the internet. It's got throttling and retries built into all of that. And as you saw Sam do, why not just hook it up to Step Functions? Step Functions, an excellent product that can be used for all this workflow automation. And you could get items, put items, your Step Functions can wait for callbacks and do a whole bunch of stuff. So I really hope you're sort of starting to see some of the power of what actually an event-driven application is. It's one of my personal bugbears that we have this term serverless that we love, but actually the term serverless Lambda was never started with the idea of as being a serverless thing. It was actually the idea of being an event-driven application. Event-driven application was what Lambda was built for, initially built to process S3 events. Now it can process DynamoDB change data events here as well. But yeah, this whole concept of building event-driven applications is already and is going to just be super powerful going on to the future. So I really wish and hope that you can take advantage of that. And hopefully Sam showed you some cool ways that maybe sparked some neurons in your brain. They did certainly in mine. So just going back a bit on some of the other kind of things that's been going on in the whole sort of serverless world, which we're putting at the end of the show today, because Sam did need to head off. Eric Johnson, who is a co-host and a colleague extraordinaire, has actually built with his own brain, incredibly, this Amazon API Gateway CORS configurator, which is under preview. And you can go to cors.serverlessland.com. If you're not aware, CORS is a partly sort of security system that is built into APIs and into API Gateway. But you know what? It can be a sort of little bit of a challenge to understand and get going. So Eric has built this awesome configurator, which shows you exactly what you need to add into your global sections and your Lambda function, what you need to add into your REST API resource for your API Gateway, and all of the information that you're going to do. Really makes it much more simpler to be able to understand and be more successful with CORS rather than getting frustrated with dear old CORS. If you are getting started with serverless, Ben Smith's Getting Started Guide is really super useful. Doesn't assume you know anything about serverless. Helps to talk about what your business logic is and APIs and things like that, and it really starts in an accessible way. And the cool thing is it's all written with the framework of a developer in mind. So it's all written from the basics of using your IDE to learn about service. I've got a blog post series which I've been nearly finishing, which is all about building well-architected serverless applications. So when James is talking about building and the coding and all this kind of thing, sorry, Ben is talking about the building and coding, I'm looking at sort of more of the day two operations, but then how you then build your serverless applications to be better, to operate better, and to have better security, better operations, better reliability, better performance, and have better cost optimization. So there's a whole series. I'm going to flick through just some of the blog posts in a minute just to show you what some of the latest ones have been up to. Sam did show the serverless patterns. This is the serverless patterns collection. If you're using SAM or the CDK, this is how you can connect things closely together. So this is super useful. Infrastructure as code templates, and you can copy and paste to connect DynamoDB up to Lambda, to connect API Gateway up to Lambda, a whole bunch of different products and services you can see on the left there, and this is really SAM and CDK code that you can grab and use to build your serverless applications really easily. Looking at what's new in serverless over the past week. If you're a Python developer, hopefully you'll be interested that Python 3.9 is now supported. EventBridge spoke a lot about that today. So the EventBridge notifications for the EC2 image builder. So it's just another event that EventBridge is able to process and use. Cloud9, if you don't know about Cloud9, it's our sort of IDE in the cloud, all browser-based. And there's cool new features to be able to browse CloudWatch logs, S3, and use EC2 instance profiles, which is super useful. Then just looking at some of the recent compute blog posts, there's Eric Johnson's configuring calls for API Gateway, Python 3.9. James Bezic has also come out with building a serverless GIF generator with Lambda. And this is all about parallelization, how you can sort of use Lambda to be able to do a whole bunch of things at the same time, which is super cool. Mark Sales, who's an excellent Java absolute guru, he has come out with a great blog post, which is out today, which is increasing the performance of Java Lambda functions using tiered compilation. And you can get literally between 30 and 60% better usage for performance from your Lambda functions using some of the cool tips and tricks that he's highlighted in his blog post. So really take a good look at that. Mobile push notifications from James. And then my well-architected serverless one continues, resiliency, and then performance, parts one and 2. And in fact, that is incorrect. I apologize for that. Part 3 landed today. So it's actually 3 parts on serverless application performance. And I'll do a quick showing on what that looks like shortly. Let me in fact jump to that. If I can bring up my other browser, and I've got far too many windows open. So building well-architected serverless applications. I'm just going to post the link to this in the comments. And this is basically my blog post series, which covers the pillars of the well-architected framework. And they are, as it mentions over here, operational excellence, security, reliability, performance efficiency, and custom optimization. And each of these links over here is a whole blog post which goes on to various ways with some opinionated, hopefully helpful to use guidance, which is going to show you how to build well-architected applications. So just for example, just looking at the first one, operational excellence, how do you understand your serverless application's health? Well, I go through in some detail how to look at some of the provided out-of-the-box metrics. And this is going to go through. So as you can see here, I'm looking at CloudWatch. These are some of the things that are built into CloudWatch, how you can use some of the overview views, the cross-service views. So across a whole application, you can look at some of the other kind of things, how to set up some alerts. I'm just flicking through quickly over there with conditions and notifications. How to use structured and centralized logging. Really important for your serverless applications because they are distributed. You need to have a good logging way. I look at the embedded metrics format. The embedded metrics format is a super useful and super duper cheap way to create metrics for your serverless applications. And so that was part 1. And then part 2 over here was to jump into using application business and operations metrics. So this is all talking about how to add custom metrics into your code and how to then add some tracing information so you can graph, how to do queries with CloudWatch Logs Insights and all things like that. What I'm going to do is I'm just going to pick the previous one, the most recent 3 ones, which are all about the application performance. And I've got some really cool simplified information I've hopefully done on how Lambda works with, what we call cold starts and warm starts. And this is all information and some just useful tips on what you can do to improve your function performance. So this is the startup time, what you can do, how you can measure it, how you can use X-ray to see exactly what is happening with your Lambda functions. Some CloudWatch Logs Insights, which is a super cool query language. And I've got some queries over here which you can use. So there was some environment. What is this one? Minimize your deployment package size to only its runtime necessities. So this is some information which can help you importing the SDK, for example, and just how to have better performant Lambda functions. Then concurrency, asynchronous and stream-based invocations. This is a whole bit of information I put together on how to understand the difference, why asynchronous is so useful, and how it is super helpful, particularly for event-driven applications, and giving better information, quicker information back to your customers. So measure, evaluate, and select optimal capacity units. So that's all about sizing. So how do you size your Lambda functions? How do you choose what sizes you're going to do? Using Alex Castelbone's the Lambda Power Tuning tool. That's super useful. I explained that over there. I then talk about some of the different ways that API Gateway can be used, and step functions can be used for the orchestration. And then the blog post that came out today is just talking about how to use native cloud service integration rather than building your own tools and building your own integrations. Maybe you don't even need a Lambda function to connect these various things together. So yeah, that would be super useful to be able to connect directly without having to use Lambda. Things like AppSync using a VTL resolver rather than having to use a Lambda function to read and write from DynamoDB. EventBridge, we spoke about a lot about that today, and how useful that can be. So this is, how to use caching and a whole kind of things. So there's literally, I'll go back to the first blog post in the series, and you can see each of these blog posts has got a huge amount. Did you know what the token bucket algorithm was for API Gateway and other kind of things? I go into detail explaining exactly how the token bucket algorithm works. Do you even know what JWT tokens are? I dove deep into that and explained what JSON web tokens are, how they work, what they even look like. And that's in this security post over there, which I'm just going to see, how to use API keys and usage plans. For security, resource policies, temporary credentials, CI/CD, auditing permissions, using different stages, using canary rollouts and phase deployments. There's a whole bunch of stuff there. So I'd love it if you read this whole blog series. It's hopefully got something for everybody. And anyone who's building serverless applications, you want them to be operable, that are more simple to operate, more simple to architect, and you can understand the scaling mechanisms and the cost mechanisms and the performance mechanisms of them much easier. So it does jump around quite a bit because it's based on the well-architected framework. Huge bunch of information over there. So I encourage you to take a look, and hopefully it's going to spark some interest in you in how to build better serverless applications. So Serverless Office Hours next week will be all on AWS Lambda. That's on September the 7th. Eric Johnson's going to be your host. And James Bezic on our team is also going to be taking you through the serverless gift generator using Lambda. So that's going to be same time, same place next week on Serverless Office Hours. And of course, for all things on to do with serverless at AWS, please look at serverlessland.com. We've got serverless patterns. We've now got the calls configurator. We've got events coming up. We've got videos. We've got learning paths. We've got the blogs. I'm sure I've forgotten something else, but plenty more information on serverlessland.com. So thank you so much for joining us this week. Thank you so much for Sam Dengler for showing us some really cool DynamoDB stuff. And please send us any questions you may have, either via Twitter, I'm Julian_Wood, or via some of these other various chat channels. And we'll see you next week, and enjoy building your serverless applications. Thank you very much for joining us.